Inventions That Changed the World by David Mall. Penguin Readers, Level 4. Text copyright David Mall 2005.
Chapter 3. Navigation. Imagine that you are going to sail a boat across the ocean, and you can take with you either a watch or a compass. Which one do you choose? The answer, of course, is a watch. You can use it to find south, as any outdoor person knows, but it will tell you something else, something equally important. This knowledge has saved many sailors' lives. The sun and the stars. If you can tell how high the sun is in the sky at noon, or the height of the North Star, Polaris, you know how far north or south you are. This fact was known to the earliest sailors. To measure this, Arabs used a piece of wood tied to the end of some string. By the 16th century, European sailors were using a similar tool, but made of two pieces of wood with numbers marked along the longer one. 1,000 years before this, John Philoponus of Alexandria had described a new instrument which could take better measurements. It was in the form of a circle and had a map of the stars on it. This was also an Arab invention. You could use it to find the time of day, the time the sun came up or went down, and the direction of different places. Because it could tell the direction of Mecca, it was popular in the Middle East. Although this instrument worked very well, it was quite expensive, and in time, a simpler form appeared. This was shaped like a quarter circle. It had a piece of string hanging down. You pointed the top edge of the instrument at a star, then held the string in place and read the measurement. But even this was too expensive for most European sailors, and they continued to use the simple tool made of pieces of wood. An important improvement on this was invented in about 1594 by the English captain John Davis. He sailed a number of times to the Arctic and gave his name to the area of water between Greenland and Canada. Because it was very difficult to look straight into the strong Arctic sun, he decided that the navigator should use the shadow of the sun instead. The navigator looked at the line between the ocean and the sky through the holes A and B. He then moved holes A and C until the sun shone through hole B. Then he added up the measurements on the two curved pieces of wood. This new instrument became very popular. It gave better measurements, and it meant that navigators didn't have to look straight into the sun every day and maybe go blind in one eye. The compass and maps. Although all of these instruments worked more or less well, there isn't much difference in the Mediterranean between the height of the sun at noon in, for example, Geneva in the north and Alexandria in the south. So, early Mediterranean sailors also kept careful records of the movements of the ship. For this, they needed a map, a way of knowing their direction of travel, and a method for measuring the speed of the ship. By the 3rd century, Chinese scientists knew that a type of iron-rich stone had special qualities. They learned to cut a piece of this stone into the shape of a spoon with a very smooth bottom. This was placed on a smooth, square metal plate. When the spoon turned and stopped, its handle pointed to the south. This was the first compass. By the 11th century, people realized that a very thin piece of metal could be placed on this stone, and in time, it learned to do the same thing. If the piece of metal was then placed on water in a bowl, it also pointed north and south. Chinese ships commonly used compasses like these to tell which direction they were sailing in. Sometime later, the compass was known in Europe too. It seems that it was discovered independently on both continents because the idea doesn't appear in Indian or Arab writings. By 1190, Italian sailors were using needles on bowls of water. To tell a ship's speed, early sailors tied a piece of wood to some string with some knots in it, each one separated by the same distance. They then threw the wood over the side of the ship and counted the number of knots as the knots ran through their fingers. The number in a certain length of time told them the speed of the ship. This was done regularly, and the results were written in a book. Today, although instruments to measure speed have improved greatly, we still describe the speed of a ship in knots. A knot is equal to 1.85 kilometers an hour. From a very early date, people knew that the world was round. In the 3rd century BC, the Greek scientist Eratosthenes decided that the distance around it was about 46,000 kilometers. This isn't very different from the correct figure of 40,000. Early map makers, like Ptolemy in the 1st century, had to use their knowledge of the stars and travelers' reports of distance and direction to decide where places should appear. Naturally, they knew most about places which were closer to home. Europe, the Mediterranean area, and the Middle East were mapped quite well, but they thought the distance to the Far East was greater than it actually is. All of this early knowledge was lost to the West when the Library of Alexandria was destroyed in a Roman war in the 3rd century. For the next 1,000 years, Western mapmakers took many of their ideas from the Bible, filling their maps with places from it. In the Arab world, more scientific methods continued, and these were used for Western mapmaking from the 12th century when Europeans began to read Arab writing. Between 1271 and 1295, the Venetian Marco Polo traveled to the Pacific coast of China. He was able to give many details about distant countries, and these were added to the maps of the time. The best maps were, of course, very expensive, and ordinary sailors used much simpler ones. These contained a lot of useful information about winds, the movement of the ocean, and the shape of the land when coasts were seen from a ship. It is interesting that the Chinese had similar guides at the time. By the 15th century, quite good maps of large areas of the world were being produced, but there were still some problems. Christopher Columbus, Colon, a navigator from Geneva, looked at the maps of the time and decided that he could reach Asia by traveling west. He was correct, but the position of the Far East was still uncertain. The maps told Columbus that it was 10,000 kilometers closer than it was. This is why, when he reached America, he thought that he had arrived in India. Maps are, of course, flat, but the world is round. The Greeks and Romans had tried to solve this problem, but their maps weren't very good for navigation. In 1569, a Flemish mapmaker called Gerard Mercator invented a new and very simple method, and his name can still be found on many maps of the world. He imagined putting a sheet of paper around the world and then shining a light from the center of the earth through it. The different parts of the world could then be drawn on the paper. A map like this has its faults. Countries near the North and South Poles appear bigger than they really are. But a straight line on the map is also a straight line for traveling, which is a great advantage. So, sailors could simply draw a line and then read the direction they wanted to go in. As well as for navigation, the Mercator map is still the most popular in the home and in school. It is how most of us see the world today. East and West. For sailors, there was still the problem of how far east or west they were. They could only tell this by drawing the direction and speed of the ship on a map. But, over time, mistakes grew bigger and bigger, and quite often, ships sailed straight into the land that they were trying to reach. An example of this happened in 1707, when 5 British warships were returning from the Mediterranean. They had sailed for 12 days in fog. They hadn't seen the sun, the stars, or land in all that time, and they were very unsure of their position. The navigators on each ship had records showing speed and direction, so they compared their ideas, but they were wrong. As the ships continued north, the first one hit the rocks around the Scilly Islands off the southwest of England. Before anything could be done, 3 of the others had followed. 2,000 men died. This was only one of many terrible events. Sometimes ships crashed into rocks. In other cases, they simply got lost, sailing until men died of hunger. But this time, 4 warships had been destroyed close to home. Ships' owners and officers put more pressure on the British government, and in 1714, a new law was passed. This promised a prize of £20,000, around $2.7 million today, to anyone who could find a solution. The problem is actually quite a simple one. The world turns around once every 24 hours. Each place in the world is at a different time within those 24 hours. In any part of the world, you can tell when it is noon by looking at the sun. If you know that it is midnight in London and the sun is above you, it means that you are near the middle of the Pacific. If it is 3 p.m. in London, you are in the middle of the Atlantic. So you only need a way of knowing the time in London. But that, for the sailors of the time, was an enormous problem. There were 2 possible ways of solving it. One way was to use the stars. In 1610, Galileo discovered that Jupiter had 4 moons. He studied these for a year, noting when they disappeared behind Jupiter, and wrote down the times. He told his plan to King Philip of Spain, who was also offering a prize to the discoverer of a solution. Galileo's idea wasn't accepted because of the difficulty of seeing Jupiter's moons from ships, although it was used by map makers on land. Later in the 17th century, special buildings were opened in Greenwich and Paris, where scientists could watch the stars with the aim of helping ships tell their position. The scientists made little progress. Their solutions meant checking the position of a number of stars, which wasn't easy on a moving ship and was impossible in bad weather, and then doing a lot of difficult mathematical work. The other method was to make a clock or a watch that worked on the ocean. It had to be unaffected by changes in temperature, air pressure, or the movement of a ship. The problem was finally solved by an English clockmaker, John Harrison, who between 1737 and 1770 built a number of better and better clocks and watches. But the scientists didn't like Harrison. He was only a clockmaker. They argued against his solution to the problem, and as a result, he was only given half of the prize. He only received another £8,750 when he was an old man, after the king spoke for him. Although the first of these new watches were expensive, they were used more and more as time passed. When Captain James Cook sailed to the Pacific for the second time in 1772, he took a watch similar to one that Harrison had made. He found that the method worked very well. Radar and satellites. Through the 19th century and into the 20th century, ships and later airplanes continued to navigate by using the height of the sun for north and south and watches for east and west. Better instruments were produced for checking the sun, but little else changed. The next step forward wasn't taken until the Second World War, 1939 to 1945, when radar was invented. An airplane could either fly along a radar signal or find its position from the strength of 2 signals which were sent out from different places. Since radar signals travel in straight lines, though, the curve of the Earth limited its usefulness to a few hundred kilometers. When satellites were sent up above the Earth, this problem was solved. Today, the world is covered by 24 of these satellites and their ground stations. Now, a handheld receiver, costing less than $100, can measure the travel time of a signal from them and tell you your position to within a few meters anywhere on Earth. Navigation has come a long way from a piece of wood on the end of a piece of string.